Hi everyone, today we're talking about congruence and transformations. As a reminder, you do not need to write down everything in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful, make sure you don't fast forward too much that you miss out on something important. So as a review from last time, rigid transformations are transformations that do not change a figure's size. So you can think about it as the figure just changing in location and or orientation. So it's like you're creating a clone. Those transformations are called rigid transformations. Those are translation, rotation, and reflection because they do not change the figure's size. They just move from one place to the other or face a different direction. So the properties that stay the same are the angles. Angles are going to be the same. Side lengths are going to stay the same, so that's going to force the perimeter and the areas to be the same. Now, because the rigid transformations just create an extra clone, they actually create what we call two congruent images. So it's a new vocabulary word, congruent. So whenever you see two figures that look exactly the same, they're congruent images. Congruent is when it's when you have two figures that are exactly the same, even if they're in different positions. So all corresponding or matching angles, like angle A versus angle A prime, angle B versus angle B prime, those are matching or corresponding angles. And the matching or corresponding sides are going to be equal in measure. Be sure you jot this important vocabulary word down before moving on. All right, so soon I'm going to be introducing you to another term called similar. So right now we're just talking about congruent images. So we actually use the symbol, which looks like an equal sign with the squiggle over it. That's called congruent. They're not exactly equal because they're not the same shape, right? Like you created a new one. But we can say that they are as close as they can to being equal. Everything else is the same. They are congruent. They're not exactly the same shape though, because the same shape is still in its original position. So they are congruent. It's the equal sign with the squiggle over it. These here are examples of congruent shapes. They look exactly the same, but they're in different positions and different orientations. Next time we'll talk about similar, but you can kind of already tell what that means. As a preview, similar is when you have two figures that are the same shape, just different in size. But they're not exactly the same. So all corresponding or matching angles are equal. The angles are always going to be equal, whether they're corresponding or similar. However, the corresponding or matching sides are now not equal to each other. Because if you have a different size now, the sides are going to become bigger or smaller, right? So they are actually proportional to each other, just not the same or equal. Okay? So today we are going to talk about mapping shapes using our rigid transformations, and we're also going to use our rigid transformations to talk further about congruence. So similar is for next time, but just know that rigid transformations, since they create a clone, they are going to create congruent shapes. So as close as they can be. All right, so let's work on a problem now on mapping shapes. For these problems, you're going to need to map the movable triangle, ABC, this one right here, using transformation. So you can start moving it over. The reason why we are doing that is because we want to practice mapping shapes, so moving one shape onto the other, using a series of transformations. Up until this point, you've only done each of these separately, but not together. Okay? So pause the video and try and see what steps we can make to map triangle ABC onto the other. All right, I notice that the orientations are different. So this flat side here for the triangle is on the bottom while it's on the top here. So I'm going to actually want to reflect. Oh, gotta get out of the pen. I'm going to want to reflect, and I'm going to want to move this line so that it's reflecting over this line of reflection. Okay, so it was originally here, and I reflected it up. You know, that didn't exactly make exactly what ABC is, so I could try reflecting again, or this could be a hint that maybe reflection was not quite right. Maybe rotation, and we can turn it around so that it's matching, so we can try that. There's many different ways you can probably get there, so I'm going to try and find the shortest way possible. Or that. Okay, that's much better now. So it was a rotation, and then now it looks like we can just translate it over. So slide it on over. And look, it does create congruent images. So it falls right on top of each other. So they are clones of each other. They were just in different positions and orientations. Okay? So that's what mapping shapes is. You're going to have to play around with it, and it's really going to test you to see if you understand the difference between those three and how to utilize those three rigid transformations. For congruence and transformations, they want to know if these two images are congruent with each other. So just like before, if we can map them exactly on top of each other, yes, that means it's congruent. However, if they didn't match up with each other, then they wouldn't be congruent, right? They wouldn't be clones of each other. Go ahead and pause this video and try this one on your own. Okay, I'm thinking already that it's going to be congruent. They look very similar, but again, I'm going to want to use my rigid transformations just to test it out and make sure. So let's see, maybe we'll try a reflection. Let's use this to turn it. Okay, it'll be right there. Okay, then I can always rotate. Remember, it doesn't matter, there's not just one answer or one way to get there, as long as you can get there. So you can have different steps than me. Okay, now this looks better. Same orientation at least, and then I'll translate it over. Oh, wow. So they are not congruent because they are not matched up equally. So it's a good thing that I mapped it and I didn't just go with congruent. See how these corresponding points do not match up with each other? They looked really congruent, like they were equal, but they actually were not. Okay, so that's what that exercise is all about. Both have you practicing your rigid transformations, and the congruence and transformations then asks you, now are they congruent? Okay, let me know if you have any questions as you work on these, and I'll see you in class.